So I'm going to lead you on a journey from the dark pits of despair, from hell itself, from the depths of the pits of hell, all the way through purgatorio and all the way to heaven, where our fine lady awaits us, or man, if you're the other direction. Did anybody here read Dante's Inferno? Wow. I saw the movie. Yeah. Yeah. Brad Pitt played Virgil. Yeah. So in the book, which is a very famous book, Dante himself gets lost in this dark forest. It's a very famous sentence in the history of literature. In this dark forest, and he finds himself in this valley, and he's going down in the valley, and he gets totally lost. And he finds this really, really nice guy, which is Virgil from the Roman times. Nice, I like that you know about it. And Virgil says, look, you're going to hell. It's all the way down. There is no other way than down. But don't worry, I will lead you from the depths of hell up all the way down to paradise where your lady awaits you. By the way, that lady was...
no spoilers.
By the way, you will never read the book. I read 2.5 and I just gave up in the third one because it was extremely boring. Anyway, that lady was a real lady. He loved her very much in real life, Beatrice. She was 11 years old at that time, by the way, just so you know. Okay, so from Callback Hell to asynchronous heaven, I will give you promises that I will take you all the way there. And the most important thing to remember, you Scala guys all know it, the road to hell is paved with good intentions. So I will show you how good intentions lead directly to hell. Cake pattern, anyone? Our journey begins with code. And this code is the simplest code that does something. It opens to file an input.txt for reading and an encrypted.txt, and basically copies one to another while encrypting it. The encryption here is really ugly. It really is simple. It does nothing. But let's look at the code. So we're opening the file, opening the other file, and we have this read buffer, and we for loop on it. Remember for loops, all you functional guys? You read sync the read into the read buffer. You read into the read buffer, get the number of bytes read, encrypt it, and then write it to the other buffer. Very simple code. We all have written, at least in the university or wherever we learned programming, we all have written that code. Very simple to read, very nice. So simple, readable, debuggable. You can just single step into it. The problem is that nobody in JavaScript land writes that way. You could. Those open sync functions and read sync and write sync are real functions in Node, but nobody does it. Why? Because in JavaScript land, especially in Node land, there can be only one thread. Only one thread is available for you. So if you're doing a read, that thread is being blocked. And for single users, not a problem. For this kind of thing, not a problem. But if you're a server that is handling hundreds and thousands of requests, that is a big no-no, because you're basically making the thread, the server not scalable. And the way it is done is not to have many threads as it is done in Java land or regular
Servlet API.
Exactly. But in one thread, it's done in another way. And how do we do that? How do we make the thread not stop? And the answer is callbacks. So, we're on the way to good intentions. This is Heisenberg. What was his name in the real life?
Walter White.
Walter White. Why did Walter White do the whole drug thing? He had really good intentions. He just wanted to pay back a loan or something?
To leave money for no, he wanted to make shitloads of money before he died.
No, I think it was something like, I don't have any money, how do I make money? Really, really good intentions. We remember what happened. Well, no spoilers. No spoilers. He does not find his love of his life up there in paradise. Or maybe he does. Anyway, so how do callbacks work? I hope everybody is conversant, minimally in JavaScript, so you can somewhat read the code. This is the open, the first open we have in that code. I open the file, not open sync. This time is open, and what happens is the open just finishes. It returns immediately, and if I check the return value of the open, I get nothing, undefined unit, whatever your programming language does. But if I give it a function, it will call that function when that file is opened. So it will throw that to the operating system, okay? And when the operating system comes up with that interrupt, which says the file is open, that function will get called. And if there's an error, it will that error will hold the exception. And if it's and otherwise, the file descriptor for that read will be given. So because JavaScript is a nice language with closures, not a big problem. I just continue my code there where the 3 dots are. Looks good. Okay, now I want to open the next file. Not a problem. I'll go into that function. I do another open, and there we are. Still okay. I continue the code with the read and the writes. Not a problem. Unfortunately, there is a problem because it's a slippery slope. 2 callbacks, one inside the other, that's fine. 3, 4, 5, what we get is the pyramid of doom. Or, as I call it,
where am I?
The pit of despair.
If you remember, the pit of despair. This is the pit of despair in JavaScript. All those callbacks, one after the other. And this is just a small problem. Okay, so I have this nice pyramid of doom, or my pit of despair. But think of error handling here, where you get an error, and if the error is undefined, is not undefined, I do this and I do that. You get spaghetti code is nice compared to that. And let's look at our code in Callback Hell. Let's look at it. There's another problem. Let's look at it. What I do is, I'll look into it. This is the code that after opening does the read-write. Okay? Notice the for loop is gone. The reason being that in Callback Hell, there are no loops. There are no map, filter, reduce even. I mean, it's that bad. I basically have to revert. What do I do when there are no loops? All you functional guys?
Recurse.
Recurse, exactly. So what do I do here? There's this function read next buffer. I'll call it down below there. And what I do in it is I read the file, get the callback there. If the bytes are read, I call done. Done is the callback that read next buffer receives. Otherwise, I encrypt it. I write, and I need to give it a callback. What do I do in the callback? I recurse to read next buffer yet again. Now, notice that this is not really recursion. Just so.
When you get the callback,
Yeah.
Do you have the full stack?
Exactly. None whatsoever.
So you have continuations.
Exactly. These are continuations. This is not really recursion. It looks like recursion. What is happening here is that when I call when I call that callback, okay, it's not being immediately called. It's going to return all the way up to the JavaScript event loop, and once that write happens, JavaScript event loop will say, oh, now I need to call that callback. I will call that callback from the JavaScript event loop. So that if an exception happens here, it's worse. You don't have the stack trace. This is really, really, really ugly shit. Okay? Now, our famous chief architect, Mr. Yoav Avrami, is working on, in our project, is working on doing what is called in JavaScript long stack traces. Somehow ensuring that some piece of information is kept so that you could see the long stack traces. It's a lot of ugly stuff, and it never works totally. In essence, when you're in Callback Hell, not only are there no loops, you're absolutely right, there are no good stack traces. Okay? So yes, but I promise it gets better. And how does it get better? Yeah, and now we're going to go into purgatorio, sorry. Purgatorio, just for you people that don't know, is not hell and not paradise. It's the place where, let's say, unbaptized children are placed because they're not really sinned, but they're not really Christians, and all these kinds of gray area crimes or sins or whatnot. I'm not very familiar.
Lost was, the guys from Lost were stuck in purgatory.
The script writer from Lost should have been stuck in hell after the second season. Okay. Promises. How do promises work? Very simple. The top level, the first 3 lines. I open. This is the non-callback thing. This uses promised open. I'll show how to implement promised open in a sec. Okay, but promised open is the same thing as open, but instead of receiving a callback, it returns a promise. A promise in JavaScript is, let me simplify, is an object with 2 methods, then and catch. That's it. You can implement it whichever way you want. Remember, JavaScript is typeless. So what you do is, instead of supplying the callback here, you supply the callback here. Okay? And if you need an error, you do .catch, and you supply the error. In essence, I mean, if you think about it, nothing has changed. Okay? But a lot has changed, because now the callback is a real value that we can manipulate and we can work with to do lots of very, very cool stuff. And one of the cool stuffs is chaining the promises. Chaining the promise means that this, let's say I open the file, the input file, I get a file descriptor. This here receives the file descriptor. It can do a return and also return a promise. That promise is chained. So the .then works on this promise, and now I get the next file descriptor. And the nice thing is that .catch catches any error both in this and in this. So the error are propagated so it looks like our regular try catch. This is one important thing that can help, and it solves the pit of despair, because now the code looks to be linear, just looks, but it solves the problem. Another thing is easy concurrency. This returns a promise, this returns a promise. Okay? There is a function in promise, a static function called promise.all, which says, look, give me an array of promises, I will return a promise that encapsulates both and will be fulfilled. In essence, the then will be called when both promises have been fulfilled. So this is what I do here. I create a promise that is both of them, both promises, and then I give it a callback which receives both file descriptors. By the way, this is ES6, the next version of JavaScript. It has destructuring in it, so you can just destructure into an array of values. Yes?
Susan, one question just to make
Sure.
sure that I understand it. In the previous slide, when you open a promise, as I understand, you don't call anything actually. Yes? You just create some data structure to be invoked later. Yes?
Yes and no. Repeat the question. When you create a promise, you're just creating a data structure that will be invoked later? No. Yes and no in a way. But in essence, and I'll show how to create a promise and what happens there. In essence, once you create that promise, the code will start being done. Okay? So the constructor will immediately run the code that you want. So yes, the promised open here will immediately run. You don't have to take that promise and say .run. Okay? And by the way, it doesn't run it in another thread. It runs it on the same thread.
So it only solves the readability, right?
Yes. In essence, in a second I will show, I'll show, it solves the pit of despair. We still have problems with promises. We're still in purgatorio, not in heaven. Okay, I will show you the code, the open read write thing. I will show you how it works with promises, and you'll see we're not we're not in paradise yet. So how does promised open work? And this is assuming we have a promise class that works, as the spec says. But by the way, promises are a feature of ES6, but there are a lot of JavaScript libraries today that give you promises according to the spec. Q, Bluebird, lots and lots of them. Everybody loves writing promise libraries. Yes.
The main difference between that and the future is that then the ability to change them together.
I'm not very much aware of promises in futures in Scala. I'm guessing that they are the same. The difference is that a future creates a thread, okay? But I think there is also promises in Scala. So a promise in Scala is a future that doesn't create a thread or something like that. Okay?
I elaborate and say that when you're calling future, when you're calling a promise, you get a promise object. You can move it around. And
same as in Scala.
Same as in Scala. And
Yeah.
in the callback way, you can't. You're stuck with it. You have
No, don't ask about the callbacks. What I'm asking is the difference between that and futures.
It's the same. Yeah, so it's the same.
It's not, because you can chain these and futures.
You can change futures.
I think if you do a dot catch, if you do a dot then, etc., and you do a dot catch, it should work.
I'm talking about basically Java futures, not Scala futures, but
I don't know a lot about that. Okay. From what I know, they're basically the same. You can chain and you can dot catch and everything. Actually, we're using it in one place in our project where we're doing promises all the way down, turtles all the way down. So it's nice, and it works, and the whole chaining thing and the exception handling and everything. Okay, sorry. Let's look at promised open. So I have this promise class, and what it does is I do this. I return, remember, the function should return a promise. So the first thing I do is return new promise, okay? The promise accepts a function. Now this is going to be ooh. The promise accepts a function which I need to write, and this function accepts two functions that I use to fulfill or reject the promise. So this is my function, and the promises me that it will immediately call this function, and that's the point. In the constructor of the promise, this function that I write is immediately called. Okay? So what does that function do? It does the open. fs.open, callbacks, okay, the regular callback. And if, once I get the callback, there is an error, I call reject. I call this reject function, which I got from the promise, reject error. Otherwise, fulfill, and I give it the file descriptor. This is how I write promised open. Okay? Very simple, very strange way of thinking, but it works, and this is according to spec. Yes?
Promise here is, I'm not sure if you said it, is it a first class object in JavaScript or is it a library?
Yes. The answer, the question was whether it's a first class object is it built in JavaScript or is it a library? The answer is yes. In ES5, the current version of JavaScript, you have libraries to do that. In ES6, it's built in. Okay?
I don't think I understand the fulfill and reject. These are parameters to your function, right?
First of all, you are brave. You asked what about fulfill and reject. You are brave enough to say that you don't understand, because it took me a while to understand this, so that's fine. I'm pretty sure a lot of it. Okay, so what was the question?
They're parameters to your function, right? And
yes.
And who is in this function?
The promise object in the constructor will immediately call this function and give it something, two functions that will cause it to fulfill the promise itself or reject.
Do you have any control of the value of the reject or the fulfill functions, or they're not user API?
Whatever you want, you can put there. Do we have control over those values? The answer is you can put whatever you want in reject and whatever you want in fulfill.
But you're not responsible to provide them. It's the promise who provides them for you.
The functions fulfill and reject are provided by the promise.
And you have no control over what they do. That's what I'm asking. If you have any control over...
And do I have any control over what they do? No, definitely. But by the way, fulfill and reject are probably closures that happen inside the promise object. So they have the context of that specific object which they run.
But basically reject is translated to throwing exception when you evaluate the promise? Or
most definitely not. Okay. No. What happens when I call reject is whoever received that promise, the dot catch will happen on it.
And if there's no dot catch?
No dot catch? Oh, that's a big problem with promises. What happens when I have this chain of promises, but there is no dot catch in the end? The answer, unfortunately, currently is nothing. It will be swallowed. There are discussions, even in the ES6 language and in the browser implementations, of somehow the browser or node figuring out somehow, wait, there's a rejected promise that somebody ignored. Let's throw an exception. Let's at least tell somebody that something bad has happened. But currently, if you don't do a dot catch or return the promise to the function above, that is what usually happens. What usually happens is you return the promise to the function above. It's very similar to what happens in try catch. You return the promise, and the person that has to handle it, the dot catch will come. But in the end, you reach that top level function. In that top level function, if you don't do a catch, it will be swallowed. Okay? It's a very good question.
But is there a way to, if you want to lock the thread on purpose and be sort of like, okay, so I've propagated the promise up the stack, back to the caller of the caller of the caller. Somewhere there, I need to block for I/O, for example. Can I do that? Like, I know it's a big no-no in JavaScript.
It's a huge no-no, and you can do that.
But you showed that you can do it the other way. So
yes, you can.
So you can block and wait for the...
Yes, and when you block that, your whole program stops. Everything. Your server does not handle requests. Not even new requests. It just...
The worker thread of the... Yeah.
Exactly. The only worker thread, yes. Okay, so this is how you use promises. The big question is, how do promises work? The answer is, and I invested about half an hour in trying to write a promise library. I just couldn't. So the answer is, I do not know. And if I try to understand it, my head starts to hurt. And I just learned to accept it. What- like implicits in Scala. Okay, now look at this cool thing. The nice cool thing is that, okay, so I have to write promised open and promised read and promised this and promised that. It's another kind of hell. But no, this is JavaScript, it's a dynamic language. So we can write a function called callback to promises. I abbreviated it to C2P. A lot of times it's called denotify or decallbackify or all kinds of shit, which receives a function that has a callback and returns the same function, but that works with promises. Okay? How does it do that? Let's look at it, and I won't go into the whole details because it's a bit hair-splitting. It receives a function, and it returns a function. Okay? Well, you know what? Let's look at how to use C2P. Let's say I want to promisify or read. So I call C2P, and I give it the function fs.read, filesystem.read. I get back a function. I call it with the regular parameters of read, but I know that it now returns a promise, so I do a .then, etc., etc. How can I implement that? I get a function, that's the func up there, line 56. Line 57, I return a function. I get a function, I return a function. This is functional programming at its best. And that function, and this is ES6, we don't have that in ES5, accepts a list of arguments. It's like args kochavit, whatever, asterisk, thank you. Varargs, exactly. And obviously the new function returns a promise, so I get the promise with the fulfill and the reject. And what I do is I call, I'll show it here, I call line 66, I call the original function. Let me skip this for a second. Let me skip the args.push. I call it with the args, but I have to add an argument. What argument do I have to add? The callback that it will use. And this is the callback that it will use, line 59. This function is the callback, gets back the result args, and this is the callback, so it gets an error and it gets a result args, usually only one. And if it's an error, I reject, and otherwise I just fulfill with the result args. This works. I mean, and every promise library has this sort of thing, but it's that simple, at least in JavaScript. So now I can use it in our open, read, write code. And it's still ugly. I mean, it's better. And you get all these easy concurrency and chaining and whatnot, but it's still ugly. It doesn't look like the code that I would write or I would, learn in the university. And we can see it. I do an open on the input file. That's fine. And then I get the read descriptor, but I need the read descriptor for later. Oh, so I have to save it as a global variable or, at least local to the function, to the above function. And then I open the other one. And look here. Still no loop. I can't still use as promises are glorified callbacks. So the same mechanism that I use, which is this somewhat recursion, the same mechanism that I use is still used here. I've gone through a lot. Promises are immensely better than callbacks, but I haven't solved the problem of readability. We were promised heaven, but we have just reached purgatorio. But promises must be kept, so onward to async heaven. This is the third act. Beatrice is waiting. So, but let's yield to a little detour. I will discuss something that has nothing to do, neither with promises nor with callbacks. It's just a little nice thing that is in ES6. This is just ES6. It's called generator functions. A generator function, if somebody knows a C#, Python, true, Python, C#, very, very similar. It's not the yield of Scala, okay? It has nothing to do with that. Actually, when I learned Scala, it took me a while to figure out that it's not the same yield. So this is a function, and it's an interesting function because it has an asterisk in it, which tells JavaScript this is a generator function. This is special. And it yields the first three numbers. It doesn't return the first three numbers. It yields the first three numbers. Very similar. It's like an iterator. And I'll show how much like an iterator it is. Okay, so I yield 1, yield 2, yield 3. It's like it's returning lots of return values, not one. Okay, so how do I use it? One way to use it, that's line 7. I say for I of first three numbers, console.log I. Console.log is the print of JavaScript world. Console.log I, and boom, it writes 1, 2, and then 3. What is happening? Only is 6. What is happening underneath? What is that for doing? Let's do it manually. So this is the function first three numbers. In line 7, I just call it and get back a value. That value is an iterator. Okay, everybody knows what an iterator is in general terms. It's something that you keep calling next, 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 or whatever, has next and more. I don't remember what it is in Java. And it keeps giving and giving and giving. It's a function that keeps giving. Okay? So let's do iterator.next. It gets back a structure or an object in JavaScript, same thing, okay, which has the value 1, value 2. Each time I call next, it gets a value, but also receives a done attribute property. And the last next, I get a done true, which means that's it, no more. Okay? So that is how, and what for var I of does is exactly that. It just calls next, 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 and until the done is true. That's the protocol of iterators, and that is what JavaScript generators when I write the code above from lines 1 to 5. Okay? We could have written it ourselves. Very easy. First three numbers, no asterisks. This works. I won't bore you with the details, but I'm returning an iterator object, which has a next, next, next function, and it uses the member variable I to increment until it returns done, and every time it returns done false value this, dot I, and in the end, done true. The details aren't really important. But by the way, this is ES6 syntax also, people who know JavaScript. But the ES compiler doesn't do yield 1, yield 2, yield 3 in this nice way because it doesn't understand anything. What it does is it breaks our code into a state machine. By the way, Python does the same, C# does the same, and well, I'll talk about Scala later. It transforms it in a machine way so that in the end it works. It's you know, just don't think about it, but it will handle for loops. It will handle whiles, it will handle ifs, it will handle try-catch. It will handle everything in the best way possible. It will just create code that is unreadable at best. But I don't care. I really, really shouldn't care. By the way, if you're using a JavaScript, today there are JavaScript compilers that take ES6 code and transform it into ES5 code, and you can see that spaghetti code. But that's not enough. Iterators are interesting because they can be bidirectional. When they're bidirectional, they're called, anybody knows? Coroutines. Okay? A bidirectional iterator is an iterator that doesn't just give, it can also take. And let's look at this bidirectional iterator. It does a yield, 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 but look at this yield. Yield not only gives the upper in line 17, not only gives the upper function, the function that called it, doesn't only give it the 1, it receives an n. If you think about it, it's receiving an n from the function that is using the iterator, that is calling next, next, next. So, and then it can use that n in the next yield. So basically what we're having here is two functions, the iterator and the function that generated the iterator, and their code looks like this. This is getting called, this is getting called, and they can pass information one to another in a very nice and cool way. And how does this work in the protocol? First I call next with no parameters, I don't have anything to give. But the next, so I get a 1, that's the yield 1. Okay, and it gives me control. The next, the next 3, I say, hey, the yield that just happened, can you make it return a 3? And the runtime says, yeah, sure, and gives back a 3. So that n in line 17 is a 3, will now be a 3. So the next yield will get a 6. So this next will get a 6. And I pass it a 5. So that yield n times 2 will return in B5, etc., etc. So next can not receive a value or receive a value, and the yield will return it.
So it's implicit because the first yield is called n?
Sorry?
Like why is the 3 used for the first yield? It's just implicitly.
Because when I do a yield 1, remember, the next means run all the code. Let's say in the yield, before the yield 1, there were prints. So it will run all the prints and then do a yield 1. The yield tells the function, stop, go back, make the next return, but give it that 1. Okay? Next, now now it's here. The control has returned to the calling function. Okay? And it's stuck in line 17. It's stuck in the call, the bidirectional function is stuck in line 17. I know, it's difficult.
It's,
Yeah.
What's a good use case?
Oh, we'll see. Oh, we'll see. Believe me, we will see.
The function itself can also receive parameters? Like the bidirectional?
Yeah, sure, but it's parameters just like any other parameter. Okay, is anybody, well, you don't really have to understand it. It took me a while to really understand it. You have to generally understand the whole. That's fine. So these are coroutines. And if you thought, now we're going to come to the really, really mind-boggling part. Let's say I have a function, and that function yields promises. And now we're connecting the two things. So this function, promises, is yielding 2 promises. And the answer is, can we fulfill that promise? Can we make this right and this right work? And the answer is, yeah, sure. This is the function, line 3 to 9. And this is fulfilling it. And let's look at the code. Promises, returns a promise iterator. And then the promise iterator I call next. What happens is that all the code up to the yield and including the yield will get run. So the write file happens at that time. And what do I get? What is the return value of this next? A promise. And where is that promise kept? In the value argument of what is returned by the iterator. So now the value is a promise, and I just do a dot then on it. And call, what do I call? I call the next again on the same promise iterator. What will happen? All the code from that yield to the next yield, including that yield, will happen. So the next write file will happen.
So the generation function actually depicts the whole workflow, yes, and then it just runs it.
Yes, exactly.
It's kind of the last function kind of interpreter, and the first function is the workflow.
Exactly. This is saying, I want this piece of code to be run, and then this piece of code to be run, and then this piece of code to be run, and this thing is the little engine that runs
That's
the code here.
layer, and this is the execution layer.
Yes, that is another way to say it. So this is construction, this is saying what, and this is running it. But notice that because it's returning callbacks, promises, the whole thing is asynchronous in this mind-boggling and I can't totally understand it way.
Monads in Haskell.
Don't even think about using that word in this.
I was going there.
Okay, so
If you want to know exactly what it is, it's a free monad.
It's a free monad.
there you go.
It's a freak of function.
Okay, but this execution function, this execution code on the bottom here will not work with anything. It will work only with something with 2 yields. If there were more yields there, it wouldn't work. It will that promises will get stuck in a way. It's not stuck. It's not another thread. It just won't continue executing. This is very specific to this.
What if you hit next and you outgrew your promises? If your function yields 2 promises, you call next 3 times. What happens?
You will get done true and value undefined, and then null pointer or whatever it is in JavaScript. Okay, now let's do bidirectional. You asked about bidirectional. Now I'm going to do something very nice. I'm going to yield promise. That's the read. But because it's bidirectional, I can get back a value. That's the content. The content will be given to the right. So now I have this really nice code which just reads and writes, but does yields in the middle, and we can do the execution code. Very similar. Same thing. I have 2 nexts, the then here that gets the first promise, but the first promise returns a value, content. And I can pass that on to the next yield and make that function above get the content and pass it on.
Statement.
Do you always use the same engine?
Oh, wait. This is very specific. If I had 3 yields here, it wouldn't have worked. Let's generalize. Or in other words, incredible question is, can we generalize it to more yields? And the answer is yes. This is very similar to read buffer, a read next buffer. It uses recursion, the same mechanism, okay, to make a promise iterator be fulfilled until the end. I don't want to delve into it, but it's the same. I first call the next, and then if it's done, I'm done. Otherwise, I continue iterating. What is continue iterating? It's calling the then function, getting a result, and in the callback, doing another iteration with next, and recursing on it. Remember, it's not really recursion, it's async recursion sit. But in the end, async is a function that will take any iterator and get all the values until it's done. This is the generalization, and it's as simple as that. Well, there's no error handling here, but just a little bit more.
Exactly, engine for all your
Generating.
Exactly, and we are in async heaven. Look, this is the main. This is exactly like the main we would have written in the sync world. Exactly, except for small yields here and there in functions that return promises. But look, the for loop is back. I can read it. Debuggability, well, remember, it's all totally, it looks synchronous.
Debug it as well?
Well, if you put breakpoints, because remember, it is asynchronous, so you can't single step across a yield, but otherwise, yeah. But it reads, for loop, etc. Everything just works. I can comment it, I can understand it. I don't need to make convoluted code just because I need to use a promise monad or something. Okay?
is it true that the function main just returns an iterator without actually reading files, opening them, etc.?
Yes, it is true. Main just returns an iterator. If you just call it, it will do nothing. And async, in line 22
It
below,
opens files
without knowing what it does. Exactly. This is beautiful. Sorry. There we go. Yep.
Except for being horrible.
It's like I mean, it's like, well, the first it's like sex. I mean, don't think about what is happening. Just enjoy the ride. Okay, and compare this to the synchronous. This is really perfect. The future. This is ES7. ES7, they so much liked it, and they so much liked what Microsoft is doing in C# 5, I think. And they want to add async and await as keywords to the JavaScript language. So instead of yield, I do await. But it's still a function that returns promise. And instead of calling the function main a generator, I just say that it's an async. Okay? And now the whole thing works as part of the language. Hopefully debuggers will understand it, and maybe we'll get long stack traces as part of the whole thing, and everything will start becoming more like sync code, but still being asynchronous. It's still one thread. Remember, this code looks like it could have written in a multi-threaded environment, but it still runs in one thread. So, from Callback Hell to Async Heaven, our journey is complete. Thank you.